Yo, yo, yo. What's up, what's up, what's up, everybody? Welcome back. Today, we are working on our virtual GPU, and the goal for today is to finish it to the point where I feel happy with it. This is our GPU running an OpenGL application. There's a monkey head in here that is rotating. And it is not, it doesn't look good in any way, shape, or form, right? There's some pretty obvious problems that we can see here. One is there is no depth mapping correctly, so you're seeing like triangles behind show up in front, and we are seeing no pretty colors, right? We're just seeing red and green. It would be nice to show like some sort of image on this guy that represents a monkey, right? Suzanne the monkey, yeah, from Blender. So the goal for today is to make it look more like this, where this is like another version of the OpenGL app running in like a normal OpenGL context. So we might be wondering like, what are we talking about here? Why are we talking about like a GPU? This is QEMU, a virtual machine. We have a PCI device implemented in QEMU that is rasterizing triangles from a program that has been uploaded from OpenGL, right? So we've had to implement a kernel driver to talk to our PCI device, as well as an OpenGL driver that knows how to like compile a OpenGL shader into something that our GPU can execute. So what we have is we have this like library we call libgpu, right? And the majority of the work that's going on here is in this shader thing, right? So Mesa will compile a shader into like some sort of like intermediate representation. We will take that intermediate representation and turn the shader into a chunk of commands. So we're basically mapping some sorts of behavior that OpenGL or Mesa is expecting from a GPU into something. So we have like a command fmol, and this will take like an input variable ID, I guess, two input variable IDs, and then multiply them together and store them in an output, right? So if we look at like fmol in here, we take A and B, we look up some things in a map, which is very slow and stupid, but whatever. We just do like a little multiplication and we spit them back out, right? We're basically doing this for a variety of instructions. And yeah, today I think I just want to see how to make it look a little bit less crap. Sorry for the poor explanation. We've explained it many times, so I'm trying to like cut it down, and I think by cutting it down, we've lost some details for sure. But the plan for today is just basically enable depth testing to try to get like the UV coordinates showing on the monkey like in a way that doesn't look like a bunch of triangles, individual triangles. We should be able to see those as like one contiguous red to green blob with maybe a couple UV seams. Then when we get that, then we can create our texturing test case where we like apply the texture back to the monkey, prove that it works on like not our GPU. And then once we do that, certainly our shader will stop compiling. We're gonna have to like fix that. There's gonna be some new instructions probably sent to the GPU for texture sampling that we'll have to implement. So we'll have to implement 2D sampling, and then hopefully we'll see something pretty. And then hopefully once we get there, we can say, we understand how a GPU works, we're happy, we can move on with our lives and do something else. So let's start with enabling some depth testing. So if I remember correctly, in Mesa, hold on, let me get into the right environment. I think I am not in the right environment right now. Let's get there. So if I remember correctly, in Mesa, we had to enable a depth texture. We had to ask OpenGL, our OpenGL context, to give us a depth texture. So if we go into like here, and we go into main, we look for like our EGL initialization, we had to specify that we want a depth buffer that is like part of the normal frame buffer. And what we had to do to implement this, to get this working correctly, was we had to go into our Mesa implementation, which is like Mesa being the OpenGL driver, like framework, I guess you could call it. We had to go in here and say, we support something that's like RGB texture. Let's see. Maybe we can like get log and that will show us. None of these. Here, we had to say we support a texture format of Z32U norm. Okay? Which means that I think what happens after that, if we enable that, is that the Mesa framework will like create a resource and he will like create a texture with that thing. So I suspect that we're going to have a depth texture that we can write to. And we should just kind of go see if that exists. So when we set up our drawing, I believe somebody somewhere says, could you draw to this texture? So we call like we call this like draw VBO, or let's look at like clear. When we clear the screen, we say, hey, GPU. Well, we say, hey, kernel driver, could you ask the GPU to run this clear call? And this clear call has like some parameters, and one of them is like the currently bound texture. Okay, so where do we set this? We set this on set frame buffer state, and this thing has a Z buffer in here that we should probably propagate to the kernel as well. I assume that's what this is. So can we look at that and see if that is something that exists? So this should be zbuff. Like this, I guess. I don't know, man. And then let's just see if that is sane. So we'll say, yo, what is this thing? ZS buff is, maybe this thing will have some like interesting parameters on it we can look at. We'll say that it has like this handle. And what else does it have? He's gonna have like a width and a height, probably, and a depth. Let's take a look at that. So we're gonna look at width, height, and depth. I think these were you. And let's just kind of see what we're working with here. Okay. So we have width, height, depth. Pipe resource is not a pointer, so these should be dots here. Do you play video games? What do you like? Yeah, I play video games. I've been playing a lot of Dota recently because my friends play. I don't think I would naturally play Dota by myself, but since my friends are into it, I play. And then I used to play a lot of Apex, but then they took it away on Linux the other day, so I stopped. I'm playing some Trackmania, and then I used to play a lot of like Fortnite and Counter-Strike. Pretty much, I'm not much of like a single player gamer. I can't play like a single player game and get like into it, but I do like winning. So I like games where you can like assert your dominance on another person. My friend told me one time, he said this as a joke, but he's like, fun is zero sum, right? And I was like, that's the craziest thing I've ever heard. But I also think that I do think that. Like, I think that like for me to have fun, somebody else has to not have fun. The only exception to that is Trackmania, and that is like the most competitive single player game I could play, because like I'm now just like playing against myself in the past, and like blue number good, red number bad, and like it's still got the like I have to have felt bad by getting red numbers to feel good and get a blue number. Like that's the kind of like the only thing that drives me is like I want to, if I didn't feel shitty for like an hour trying to improve my time, then I wouldn't feel good when I got it. Like either me or somebody else has to have felt bad for me to feel good, which is probably incredibly unhealthy. I should try Deep Rock Galactic multiplayer co-op and fun. I tried it once and I was so bored. I never played again. Just like what, I just go like fucking like hit a rock for an hour? That's fucking stupid. Okay, sorry. We have to focus. We have to focus because we're trying to do our last GPU stream, and if we don't get to the end of it, then we're gonna have some problems. So let's run our virtual machine and rebuild our library and upload the latest version of our Mesa shared object to the virtual machine, and then run it. And that should give us our new little fprintf there. Okay, so we're seeing a buffer handle of 2 with a width of 1024 by 768 by 1. So this looks really promising. This looks really promising that we did, in fact, get a Z buffer, and that Z buffer is on the GPU. So really, all we should really have to do is ask the GPU on our draw call to leverage that in some way, right? So can we call this like depth texture handle is equal to CTX zbuff handle, right? If we do this, then we should be fucking chilling. Now he's like, that doesn't exist. Well, he's not saying that, but it does. That is what it means. And that's because we need to go into our Linux kernel driver and add that. So I guess we should start from the other side. We need to go into like the implementation of our PCI device and say, give the Linux kernel a way for it to ask the PCI device to leverage a GPU resource for depth buffer. So let's go look at that. So if we go into like QEMU and we look at our implementation of our PCI device, somewhere there's like exec shader pipeline. So the way that these like commands work is the kernel will write to this like memory mapped range for like that the PCI card will like basically get packets for. If I write to like this memory address, the PCI, I think it's called the PCI root complex, will like see that right on the bus and go like, oh, that means that I'm supposed to send this value to that guy. And so the value that we get is like a command. We say the first byte of the thing you send us is like the command, and then we just like shove a bunch of other stuff in here. So if we should just say, hey, give me the depth texture handle, and then we'll pass that thing in to our actual render code. And so that's really all we have to do here. Then we just know that in the kernel driver, wherever we call exec shader pipeline, we just have to pass in that thing now. So we set it after texture. So this goes 12, 13, 14. And this is going to be depth texture. Now, this depth texture needs to come from a handle lookup. So there's a hardware ID for this thing as well as like a user space ID. So we have to go from user space ID to hardware ID. And then it looks like we need to ask this thing to give us a depth texture handle. And that should be everything. So here we should be able to go into build QEMU, build this. Hopefully nothing falls over. He's mad because, right, our implementation of GPU needs to take in that thing when we exec pipeline. So we're going to look for uint64t depth text. Boom. Which means that our implementation of that function needs to take in a depth texture here. Okay. And that means that this guy needs to take in a depth texture here. Okay. Okay, and then that means that somebody, whatever this guy's getting used, needs to do something with it. But for now, can we actually just comment that? Because I need to draw the line somewhere. So can we just do this for now? And then make sure everything else is still working. So we rebuild our GPU library. Actually, while we're here, I might as well re-enable recording. So graphics input dot JSON. So this will like record what parameters were passed to our GPU when we call like execute the shader. And that will allow us to replay it without having to go through the whole loop of everywhere else, right? As long as this thing like exists, as long as like all of the data that we need has made it into our GPU library, we should be able to kind of just like work in that space for a bit. And then once we figured out the right answer, come back and integrate everything. So I think this should do it. Okay, and then we can go back to, I should make sure that we're not like merging commits to something else. So this is fine, okay. We didn't build, now we should be able to build QEMU because that API now is correct. Cool. And then we should be able to build Linux as well. Okay. We have to wait a little bit. The first build every stream is slow. I don't know why. Never looked into it. But it just like it seems to think that a bunch of things are out of date that are not. There must be some sort of like system library that it's depending on that gets like a timestamp updated every time I restart the environment or something. What do you think? Is it better to use JetBrains code while writing program or Visual Studio Code? I think it really doesn't matter, man. I think whatever you prefer. The things that I'm looking for when I use an IDE is that it is not slow, and that it has like good understanding of the code I'm writing. Visual Studio Code can definitely provide that, and I'm sure JetBrains can too, although I haven't used it recently. So I think it doesn't matter. I think it doesn't matter at all. I think stressing over your I think it's like good to think about your editor, but if you are spending a lot of time thinking about it, then that is not good. We are crashing because Sphero GPU has an invalid module format. That's interesting. That's new. Never seen that before. Oh, probably because I need to run. I fucked up. It's fine. I just need to make sure that I run this run script after I build the kernel, because it packages like a RAM disk and puts the kernel module in there. And so if it's wrong, then it's wrong. Okay. So we'll compile our OpenGL app, send it over to the virtual machine. We're now failing to execute graphics pipeline due to invalid texture ID. So that's not good. That's not good. That kind of indicates that what? Because we aren't even trying to use the new texture ID. That indicates that we fucked up the messaging format in some way, shape, or form. So can we look a little bit carefully here? Exec shader pipeline. So this is supposed to take in. Yeah, this is supposed to be 13, 14, 15. Oops. I accidentally overwrote the bottom, the upper half of the texture, of the color texture with the depth texture. Oopsies. Oopsies. So that means we rebuild the kernel. And then rerun our run script. Okay. Let's see. Let's try it again. Okay, so test app dev Gerard card 1. Okay, there we go. So now we have recorded some graphics input successfully, which means that we can go into our libGPU now and start like playing with it. So where is, here we go. So I think we want graphics input. I think we didn't use plural this time. And here is our current output, so it's good. Nothing's broken. We are still seeing the monkey for sure. And now all we want to do is try to figure out how to like leverage that depth buffer. So here, where we said fix me, find the depth texture, let's do that. So here we're going to say depth texture is equal to depth texture like this, which means that we need like an implementation of this thing. So we need depth texture is also a texture. And now we have a problem. So we have error missing field. Oh, right, because when we record our inputs, we're recording this structure, which needs the right. Fuck, he needs the right data. Okay, we need to do one more recompile and run. One more, but it should be quick. So he's basically relinking the latest version of libGPU. We run this thing. We take a look-skis and we wait for him to boot, and then we run the app, and then it should be good. And really, we should just leave this open instead of closing it so that we don't have to. Oh, we'll see. Maybe it's fine. Maybe it's fine. Okay. Can we try that? Okay, cool. So nothing's broken. Everybody's happy. And now we can start trying to leverage this thing. So I think that what happens is we run our shader it moves all the triangles around, and we should just have a z value that we can just like put into this depth texture. So can we do that somehow? Let's see. I think it's like when we go to pixel coordinate, we should keep the z value, I suspect. So we take in the, we have to do like our homogeneous coordinate division. So like OpenGL uses this like kind of fun format where it's a 4-dimensional vector, a x y z w, to represent a point in 3D space, and that is like the 0, 1, 2 points divided by the third point, or the fourth point, I should say. Because to do perspective in OpenGL, or to do perspective, you need to be able to represent like x over z or y over z, because like your horizontal and vertical distance is like shrinks as you get deeper into the screen, right? So you have to do a division by z, and so this is how you can represent that, is by adding another element to your vector. There's other properties of this thing that are nice, but just like if you've never worked in 3D, you might be like, why the fuck are you doing this? And that's why. And I think for now, can we just like write out the z value? So when we rasterize triangles, maybe we rasterize out to a depth texture as well. Okay. And what we'll do is we must take in the depth texture here. Okay. And I think in OpenGL, or sorry, in the Mace implementation, we claimed that we would store each pixel as one U32 value. So I think that this is actually kind of just happens to work out okay. In the color depth, the color texture, we're storing it as 4 U8s, which happens to line up with the U32, and our depth that we're storing as U32, which happens to line up with the U32. So luckily we don't actually have to change anything here, which is kind of funny. It's actually pretty fucking sick. So we go like this, and then I guess we should assert for now that the depth texture dot width is equal to the color texture dot width. I'm not really sure that that's like a true constraint, but we're making that assumption for now, so we have to assert it. You know, it is what it is. Okay, so now that we have that, in here, we should be able to just kind of like interpolate the depth somehow. Which I guess we'll just call, we can just do it manually. So we'll say the depth output is the A coordinate times sorted triangle. Yeah. Sorted triangle 0.z value plus the second ratio times the second component plus the third component times the third ratio. And then we should, this will give us like a floating point number between 0 and 1. Should be. So we should be able to then just write out clamp cast F32 to U32 val times 2 to the power of 32 minus 1. Okay. Like this. And we're clamping it from 0 to stood math max int U32. In fact, we could just write max int here. That makes more sense. Okay. So this should be the depth output. Okay. Okay. Seems reasonable. Clip space is -1 to 1. Window space Z is 0 to 1. Do we handle it by default? Did I just fuck that up? I thought that clip space was 0 to 1, but maybe I'm just. Or I thought that the perspective matrix turned it from 0 to 1. But maybe that's stupid. We'll find out. Maybe we will say if depth output f is greater than or less than 0.0, or depth output f greater than 1.0, stood debug print unexpected depth this value. I do kind of believe you because I mean that was my mental model as well. But then when I was deriving the perspective matrix by hand, it seemed very 0 to 1. So not sure. Not sure. Let's take a look, skis. We can always just do depth output f plus 1.0 over 2, right? We can always just do this. Right? We can always do that. But let's start here. Okay, so yeah, he saw everything 0 to 1, which is kind of interesting. Projection matrix traditionally takes you from view space to clip space. The transformation from clip space to window space is not controlled at all by the user in OpenGL and is expected to be done hardware. Yeah, I believe that. I believe that. That is my understanding as well. I don't know why I got confused. Space Z. Not at all is a semi. There's a GL viewport and GL depth range. Okay, that sounds right as well. That sounds familiar. So, all right, sure. So I guess our projection matrix just is doing what we expect, but maybe is not quite correct. So we could just half the precision of this thing, and that's maybe not the end of the world. Yeah, fuck it. I guess you're doing your own GPU and driver. You make the rules, though. That's true as well. If we want to be OpenGL conformant, we can't make the rules, but we also can make the rules. And so I'm okay with taking a cheat there because I don't want to think about it. So can we just, like, in our replay, write out the depth data as a new file? So can we say that we want a depth output path as the third argument here? And we'll just kind of do something that's very similar to what we were doing before. However, before we were writing an RGB image, and here we want to write a kind of like U32 black and white image. So what's like the PPM image format? I think there was a way for us to specify the maximum value of these things. So where's our like P32 bit? Portable float map? Not really what I'm looking for. Grayscale. RGB alpha, grayscale alpha. I may think that maybe if we use the ASCII version of this thing, we can ask for more precision, or we can just clamp the precision as well. That's like an option as for sure. Maximum 65535, maximum 65535. Okay, fuck it. We'll just I think for now, I'm just gonna clamp it down. Because that's easier. We'll use the existing RGB format and we'll just kind of figure it out. So how do we want to do this? We do basically all of this stuff. Do it again down here. Except we say depth output. Depth writer. And then we are looking for depth texture here. Depth texture here. Okay. And then we are extracting the value as a U32. So we're going to be like stood mem to value, bytes to value. So we're looking for a U32 out of this to start plus 4. Okay. And then we are just going to do something that's like val shifted right by 24 will give us the approximate depth value. And then we can write that byte 3 times. So we'll do like this, and then we'll do, maybe we'll do like val u8 is equal to val shifted right by 24, and then truncate. Okay. And then we can just be like, I'm going to write val u8 here. Good enough for me. Good enough for now. Doesn't have to be perfect. We did forget to write depth here. As well as here. But does everything else look kind of right? Depth here. And then this needs depth texture. All right, that's it. Index out of bounds. One, two, three. So we have, oh, oops. This goes here. And then we want to open the depth output. Okay, how's that look? I mean, that looks like something, for sure. For sure. It's just that this is all really white. So can we, if I shift it by more, will I see more variance in this guy? Not really. It looks very flat. But maybe that's okay. Maybe that's okay. It would be nice to actually look at like the individual pixel values here. Can I open this in like a something where I can see if there's differences in the pixel values? So this is like 62. Also 62. I guess we're like losing precision. So we don't really know. But there's like a good chance this is correct. Like a non-zero chance. You might be able to tighten up your near and far plane in the definition of your projected matrix. Yeah, that's true. That's true, for sure. But I think for now what I want to do is I just want to, in the triangle rasterization, just try to use the value. Fuck it, you know? You know? So here, for each fragment, we're just going to be like, if the depth output is less than the existing depth output at that point. So we'll call this like, first of all, let's just say that the U32 index, let's pre-calculate this thing so I don't have to like put it everywhere. Then we can be like, yo, if this thing is less than this, greater than this, probably, don't draw it. Okay. Let's just see what happens if we do that. Oops, there's an extra self in here that shouldn't be. Also, depth is very non-linear. Yeah, no, I know. Which means you can go to white very fast unless you linearize it before storing. Yep. Fully understood. Fully understood. Looks like maybe we want less than. Okay. So the guy's still there, and then can we look at the color output? That's looking pretty good. That looks a lot like we are correctly seeing order in some way, shape, or form. That's pretty exciting. Exciting stuff for sure. I think that we have forgotten on the clear call to do this correctly as well. We need to make sure that every frame when we clear the depth texture, that we are in when we clear our textures, that we're clearing the depth texture as well. And we're almost certainly not doing that. So can we look at this kind of assumes that we are clearing the color texture. Are we executing sequentially, or do we need some locking atomics? Sequentially. We were working in happy hour on splitting out a thread to do this stuff, but we didn't ever quite get that stuff merged, so everything's just kind of happening in line right now, which is like fucking stupid, but good enough for now. So I guess we're gonna do this. It's gonna look very similar to clear. We're gonna call clear color, I guess, and clear depth. Which means that we're gonna have like clear color. Okay. And clear depth. Right. Which can be like clear. Maybe we'll call it clear U32. I don't know. We'll see. So what does like clear color do? He like looks at the texture, adjusts the pixel coordinates, and I think what we can just actually do is we can just kind of copy this into clear U32. This is going to take in a color value. And then here we're going to use color. And then in this clear color call, we're just going to take this int from float, stick it up here, turn this into a U32 color, right? And then we can just call self clear U32 with all the same parameters. And then I think everything is chillin'. We just want to do kind of like this, I guess. We're gonna have to be a little bit tricky here. So we're gonna go like texture data U32 is a U32 slice equal to stud mem bytes as slice. Okay. Then we're gonna look at texture data U32 here. And then here we're gonna have to make a color to go like 0 to 4 color. We kind of like OR this thing in. So we go color OR equals this thing, and we shift this channel, we'll call this, I guess, so that we can do, say the channel is a U32 is equal to this, and then we can do color or equals channel shifted left by C times 8. Seems reasonable. Seems reasonable to me. Not really sure that's right, but you know. I think I need to like align cast here. No. Result type. Okay, so C here, we need to int cast here. What else is it complaining about? It's complaining about the wrong amount of arguments. So I wrote self again. Good dumbass. Okay. Area news ignored. That's true. Okay. And then align cast must have a known result type. Fuck. Maybe I just can put the align cast outside. Like this. Much better. Yep, okay. So now we recompile QEMU. And we actually need to not just recompile, but we actually have to like do something here. So we need to clear color here. And let's just clear depth with uint 32 max temporarily. I just want to see what that looks like. Oops. Okay. Let's just make sure everything is still good. Okay. It's not good. We are not good. So on clear color, we're fucking up. Yeah, because there's just like a ×4 sitting there for some fucking reason. For some reason, dude. Obviously, this shouldn't be there. Because we switched to U32s. Oops. Oopsies, oopsies, oopsies. It's a hard life. Okay, one more time. One more time. Okay, root, test, app, dev, DRI, card 1. Still crashing. Fuck. Ah, because fucking y times stride now is wrong as well. God damn it. Yeah, because strides and bytes, of course. Of course. Okay. One more time. This test loop is so slow. I wish we had done more. But what you gonna do? Take a sip of the coffee. It's basically empty, so I was just pretending. But I didn't know that when I picked it up. So you can't make too much fun of me. But then I was like, once I've already started taking the sip, it's like, now what do? I have to like play it cool, you know? Okay, that's looking good. We close this. We run a replay. Just make sure that we didn't fucking destroy anything. XG open output ppm. Looking mostly fine. Except that we cleared the color with the depth as well, like fucking dumbasses. But that means that everything's working. It's working. It's working. It's expected. It's just that in our QEMU, we accidentally just used the same depth handle, the same handle here. So we actually need to take in like a depth handle here as well. Right? That's what we need to do. Our clear command has to take in a depth handle. So maybe we'll kind of put it like here. And maybe we take in the depth value. Okay. So this is going to be plus 8, 9, 10, 11, 12. Okay. Okay. So now we need to just pass over this stuff from the Linux kernel. So in the Linux kernel, it looks like this is already open. I don't know where though. So fuck it. We'll just write again, and we are gonna send like a clear command over, and we need to add in now depth handle and depth val after the color buffer. So this is gonna be we have like a DRM gem object, which I think we're supposed to clear after, which we do. Okay, cool. So here we're gonna be like depth obj and sphero depth obj, and then down here we're gonna put depth obj to clean it up. Now we're gonna be like sphero depth obj hardware ID here and here as well, but shifted by 32. And then here we're gonna take the params and we'll look at the depth color. Okay, so this is gonna be the depth handle here. Okay, which doesn't exist yet. And then all of these parameters need to be bumped up. So it's 9, 10, 11, 12, 13. Okay. And I think that lines up. These are -1 on the right side, so this does look correct. I think we're chilling. Are those line artifacts due to float precision? I think that they're probably due to like integer. I probably just like not handling like pixel precision correct. I don't think it's float precision as much as it is like I'm probably not using the center of the pixel, and I'm probably not clamping my interpolation value correctly. So like when I'm like interpolating the edges of a triangle, I'm probably sometimes putting in like interpolator equals 1 point small value or something. So there's probably just like a couple clamps that I got to do, but I also just don't really care. So, you know, this is depth, and we'll call this, we'll say this is actually a U32, and then we say the depth handle is here. Okay. So let's compile both the virtual machine and the Linux kernel and just kind of hope that everything works out. Like this, and then like this. Okay. Oops, I just fucking smacked my mic. Is it still working? Yep, cool. Cool. I forgot to put a semicolon somewhere. Fair. Make. That's what I'm trying to fucking type here. It's a hard life. It's a hard life. And then we need to go into like Mesa. And update our Sphero DRM Winces here to on clear. He's going to need to set the depth handle to the depth texture, which is great. And then we also have to set the depth clear color. So we're just gonna take like depth out of unit 32T max. And then that should autocast to the correct value. Good enough for me. Good enough for me. You know, maybe we should be rounding, but you know, shut the fuck up. I don't care. And then this should work. Okay, and then I want to go back into libgpu actually, and turn off the recording and like just run it normally, because I want to see that like the animation works correctly. So if we do this, and then do this again, everything should be kind of chilling. Okay, run. And let's just make sure everybody is doing what they're supposed to be doing. So can we run build.sh and copy over? He's copying, he's running. Not looking promising. Not at all. So why? Interesting. I wonder if the depth check is inverted. Seems possible. And then if the depth check was inverted, we were probably not clearing it, so the buffer just happened to be uninitialized memory. And we were just drawing stuff that was less than whatever like the zig uninitialized memory thing was, and we were drawing like the backside of the monkey. That's like a possibility. So can we just try? Let's just double check here. So it's like majorly black, which is also kind of weird. The clear color is supposed to be not black. So there could be some like communication issues going on here as well. Could be. I want to go into libgpu and try to look at like libzig. Demo scene ready. Yeah, it does look kind of funny, huh? Can we print out like clearing with val of this? Let's just kind of see like what the fuck are we doing? Because surely it's something stupid. Let's go away. I actually wanted, fuck. I wanted to log this hex. That makes way more sense. Unfortunately, it means we have to relink and wait a second again. No clear sounds reasonable because it was evolving over time. Yeah, that's what I think. That's what I think. And so it's likely that our condition is just inverted from what it's supposed to be, but that's fine. Let's just start with looking at the actual depth values. Oopsies. I want to log in as root, not R. Root, test, app, dev, DRI, card 1. All right. So yeah, we're clearing once with like our green color, and then we're clearing the depth buffer with 0. So I don't really feel like I understand here why the background should be like varying colors of green, which is not happening. So can we look at sphero.c. We are trying to clear color with color buff. We have determined that the color is correct, right? Because we were seeing in our logs, oops, wrong window. We were seeing in our logs that we are clearing with like a value that has varying levels of green. So that seems kind of correct. Which makes me confused here. So we get handle is the first thing. Let's look at our Linux kernel. Let's just double check all of this. So GL clear. We have sphero obj, which comes from params handle. Okay. And then we have depth object at register 7, 8, 9. So that should become 6, 7, and 8. Yes. Okay. So far, seems kind of reasonable. I guess if we have the RGBA format backwards, that could be the problem. So can we maybe try inverting this? Because before it was R is the first thing. So here we're taking the 0th thing and putting it in the lowest significant bits, which seems right to me. Alpha here should be the final thing. So we're missing something. We're missing something. Like, this should be right. This should be right. This should be... Well... Yeah, because we were seeing logs of color, alpha being the highest two nibbles, which means it should be RGBA. And like, what did we change here? We changed it from plus C. Yeah, so this was it was doing the lowest thing before. Kind of confusing. Kind of confusing. Is it possible that we fucked this up? Y times width plus X? No, it seems pretty right. Seems pretty correct. Use UN64 T star instead of UN32 T star. That's intentional. Because the hardware IDs are 64-bit. Oh, here. Although that should have the same effect. You are correct. Yeah, I'm confused about why the color isn't getting set here. What if we just don't call clear depth? Oh my god. What if we just don't call clear depth? Right, let's just see, let's bisect the problem. Is it that our depth buffer is somehow using the same handle by mistake? Or is it that the clear command is not doing what we expect it to do? All right, let's see. That's looking pretty good. The monkey itself is still looking pretty fucked up. Which is kind of confusing because I don't feel like we changed anything there. But that's okay. Okay, so it looks like clear depth is somehow breaking the color buffer. Monkey def looks like the depth check is inverted. Yeah, I would believe that. Well, I don't really know. I would think that the fact that I'm seeing anything at all is a little confusing to me. I will say that. Okay, so when we call clear U32, taking in some value, it's, I guess here, let's say clearing this texture with this value. Just for peace of mind. Oopsies, ninja and run, I guess is the command here. Aren't you depth testing anyways? I don't think I understand what you're asking. I think that we are supposed to be doing depth testing, but like the I don't understand why clearing depth is making the color buffer black, right? If our depth test is just like wildly wrong, I would expect that the color the background still stays green. That's what I would expect. But instead the background is turning black. And it's like, for what reason? So we are clearing 0 with 0, 8 with that. Whoa. Okay. What is happening there? Clearing 8 with that, then clearing 8 with 0. Then clearing 0 with 0. The fuck? The fuck? And that only happens if I call libgpu clear depth on clear. Could be some sort of like I wonder if that's like being issued by Mesa in some way. Clearing 0 with 0. That's very strange. Very, very strange. Because that only happens if I call libgpu GPU clear depth. Right? If we do if true, return true here. Does that stop? Are you getting the depth call from Mesa twice, once with depth and once with color? I guess that's a possibility as well. That seems possible. And then the zeroed out ID just happens to line up with the color texture. I would believe that for sure. I'm just gonna like double check that this is what's happening. Okay, so root test app dev dir card1. Yeah, this is. I wonder if this is like double buffering now. So this is, yeah, this looks like double buffering maybe. Or multiple calls like you were saying. But we are seeing that these values are changing. So we must be double buffering the color buffer here. That would be my guess. And then when we were seeing something bad, when we were seeing the bad behavior, we were seeing 88008800. So none of these are the depth buffer? Would be my guess. There's something something fishy going on here. Something fishy. Let's look at the Mesa code. Let's look at the Mesa code. So can we look in here for clear? What am I supposed to look at here? Buffers? Okay. What comes in here? Bit fields of pipe clear values. Color, pointers to union of FIU array for each of RGBA. Depth clear value in 0 to 1. Okay. Okay. So this is also a clue about that like 0 to 1 mapping thing we were talking about earlier. It's possible that OpenGL does the conversion for us in like shader compilation. So I guess what we want to do is we want to go like if buffers and pipe, what did he say it was? It was like a bit field of pipe clear. If we get this, we do something. So here we will start these as uint32 max as like a sentinel value for like don't fucking use this. Okay. If we have depth, we will use the correct value. So okay. And then we also have to set the depth value, which came from depth over uint32 max. That could also explain it. Usually depth is not double buffered because the compositor does not really need to use it, so you can have one copy normally. Not sure how you're doing here. Makes sense. Makes sense. I'm a little confused about like the handle here. I'm a little worried. But we'll see. If buffers and pipe clear color. What's going on here? Pipe clear color 0. And pipe clear is any of them, sure. So we'll say pipe clear color 0. Oh, we'll say pipe clear color, I guess. Then we set the color. And then also set the clear rec handle to CTX bound texture handle. Okay, so then can we also say here, fprintf clearing depth with this handle ID. And here we'll write clear. And then here we'll write clearing color with ID this. This should give us a little bit of a clue. This should give us a clue. Okay, let's quit here, ninja, and run. I thought double buffering was meant to the GPU multiple frames from fight, not introduce a sync point between frames. I thought it was so that the presentation, the thing that is currently being presented, is not the thing that was being worked on. And since the depth buffer is not presented, it would make sense for it to not have to double buffer it. Oopsies. Why is he making me rebuild the world? What the fuck just happened? This is weird. I haven't seen this. I don't understand. But I mean, we'll live. It's just very strange. It's a little concerning, to be honest, but it's fine. It's fine. I just must have touched some header that I didn't mean to. I hope everything's fine. Okay, so clearing depth with ID 2, and then color ID 1 and 9 alternating. Okay. So these are the user space handles. Can we breakpoint on... I want to look at what we're getting in the clear call here. So can we breakpoint on like this? So it also looks like the depth is always coming with the color. So we have depth handle and handle. So the fact that these are the same is quite concerning, considering we are using 2 different buffers here, right? Which means that the bug feels like it's either in the parsing of arguments here or from the Linux kernel itself. So I'd be interested to see where that is. So can we go to source Linux and look at the GL clear? What are we doing here? We look up the depth object. God fucking damn it. Forgot to write depth here. Fuck, man. Okay, that makes a lot more sense. Okay. If only we didn't make mistakes. You know? You know? So now hopefully the depth buffer is cleared with the right fucking ID. So it wasn't a bug in the kernel. It was a bug in the kernel. We were trying to extract the depth hardware ID, and we just didn't use the right thing. We like reused the same color buffer again. Okay, so now the background color is changing, but this is fucked up. So we're also just not clearing depth anymore. So can we turn that back on? Oh, we are. It's in libgpu. I think we disabled it. Okay. Zig build. And then while we're here, if we're supposed to be clearing with 0, can we look at our triangle rasterization and just make sure, like, what is our depth check here? If depth output is less than what's already there, we should be doing greater than here. We should be doing greater than, because if it's 0 is the default, then everything must be a bigger number than 0. And we just, you know, we're experimentally coming to the wrong conclusion before. Yeah, because it's 1 over z. Oh, that would make sense. Yeah. Is it intentional to clear the depth to 0? It's more common to clear to 1 and use less as depth. I don't know. Don't ask me. This is also just doing nothing. Oh, you know what we're probably doing? Maybe this was right, and I think we made a mistake on color on depth conversion. Now that you say that, it would also maybe explain why we are seeing kind of like the edges of the monkey in some way. If in Mesa, this is supposed to be a multiplication, not a division, right? We have a value between 0 and 1. We're trying to convert it to a U32, and we just divided it by U32 max. We're getting like basically unconditionally 0. Instead, we have to multiply it. So, oops. Oopsies. Usually one frame of work is enough to saturate GPU, so no need to render multiple frames at the same time, but you can still overlap into the last frame with the start of the next frame if you have a long enough pipeline. Which RCR Stun is saying, yes, thank you. That is what I was asking. Okay, that makes sense. I believe that. Yeah, line of reasoning makes sense. I think the trade-off is usually not worth it because those intermediate buffers can get really big at high res. You have enough stuff to keep pipe busy anyways. That makes sense. That makes sense. All right. Let's see what we got now. Copying over, running. Okay, so now we have clearing 1 with max int, which now I think makes sense. And now we're just not drawing this guy at all, which is kind of confusing. Because in libgpu, rasterize triangles in our triangle renderer, wherever the fuck that guy is, if depth output is greater, the condition was inverted. We're continuing if it's greater. We're trying to work if it's less. God damn it. Last time? Last call? Last call, maybe? This has got to be the one. It's gotta. It's got to be the one. Okay, there we go. That's looking pretty good. That's looking pretty good. That's definitely, finally depth testing is working. Hell yeah, dude. There's some sort of like, maybe some funny shit going on there. It looks okay. It looks okay. So you have depth already mapped to U32 there, or is it still 0 to 1? Already mapped to U32. So it's going in Mesa, I'm multiplying the floating point value by uint32 max, then feeding the uint32 into the kernel. The kernel's passing that uint32 over to the PCI card. PCI card is asking the depth to map that way. So that's looking pretty good. Looking pretty good. So what is next? Frame rate not too happy. Yeah, it's because I've got debug mode on libgpu, and we did some profiling, and it's like entirely in like hash map access and stuff. So it's optimizable. It can get faster, but you know, it's not really too important right now. Okay, let's checkpoint. We'll call this depth testing. We need to do this kind of everywhere. Depth testing. And here, do the same thing. Depth testing. And eventually I will have to clean all this up. I need to get this shit pushed. But now we do this. Okay. Let us move on to creating our texturing test case. So we will go into our test application. And let's see if we like completely nuked the code related to image rendering or if we just commented it out. I think we completely nuked it, which is annoying. That's annoying. But we have a backup of our thing in source in our like Wayland client. So I think we can just kind of like pull our model renderer code from here. And this kind of see how it's different. So we load the image. We have some texture stuff going on. And some shader compilation log fixes. So can we do like... I do not want this change. I think I want to keep this the way it was, but pull in texture manipulation. And I think that we don't really support any texture, like any like OpenGL object deletion. So I'm just gonna comment that out for now. This is all fine because this dinit call I think is just never called, so it's fine. I do not want these changes, but I do want all of this. Okay. Cool. So then I can do this to clear the rest of them, and then try to clean this up a little bit. So hello, where the fuck am I? Okay. So we need STB image. Because he needs to load the image data somehow. Okay, so let's download that. I guess we probably have that. Oopsies. Oopsies. I want that to do is to stay here, please. Which I guess we probably have in our other repo. stb image.c, stb image.h. Oh, which we already actually have here. Nice. And then does our build zig already handle all that? He does. Look at us go. So if we build this thing, how does it look? Chillin'. And so now if we upload this test app and try to run it on the like existing GPU, not ours, do we see something that looks textured? Let's see. Oops, not card one, card 0. Fuck. No, because we have to update our fragment shader still. Right, so we need to change our fragment shader to kind of match whatever was in here. Uniform sampler 2D text, and here we're gonna call texture text and UV. Okay. Why did I close the VM? I didn't mean to do that. And then let's see if this works now. Why? Fragment shader compile. He's mad. I guess we need to write down what happens in that case. Because I think we only checked logs on the vertex shader compilation. So we'll just kind of do this same thing down here. Okay. Probably there's like some sort of like old GLSL texture thing. No function with name texture. Okay, so what was it in old GSL? What was it in old GLSL? The versions of GLSL we support. Do I have a fucking Firefox window open? I guess not. So can we look at like a texture GLSL 120? Texture 2D. Thank you. Thank you. That's looking promising. Okay, here we go. There's our little textured guy. So our text case now is ready to go. And now we are certainly going to start hitting a bunch of problems. So let's run this thing on card 1. Oh, fuck. I don't know why this keeps closing. I don't really understand why. Like, if I control C over here, then it, like, quits the app over there. I don't know, man. There's something weird happening, but we won't worry about it. Test. App, dev, DRI, card 1. Oh, he's mad because invalid elf magic. Maybe because it crashed while stuff was being written. Okay, so he's just seg faulting, which is very cool. So I think that if we run this, it should just tell us exactly where the problem is. Yeah, there we go. So this is at texture image map at U inlines 577. Okay. Let's go find that and move on with our lives. Source, Mesa. U inlines.h 577 it was? Texture map? Okay, what is this supposed to do? God, my nose is so itchy. God damn. Okay. What does this do? Data for transfer to or from a resource. Ah, okay. So because we're like putting the data that we loaded from the image into the GPU texture. So we need to actually like do the copy somehow. That must be what this is. We can look for other usages of this in a minute, but seems pretty reasonable. And it looks like this is on the GL context thing. Yeah, wherever bind vs state is. Okay. All right, so it's this. So let's just start with Sphero context texture map. Then we'll just do like texture map is equal to Sphero context texture map. And we see if this is the only problem. Really? I'd have to fucking manually cast this? Fine. Fine. Where else are we crashing? Fail to set CRTC. That's fair. Because he can't be open twice at once. Okay. I guess we do the same thing again now. We're seg faulting again. Let's try to figure out where. Oh, this is kind of fun. It worked for us. I don't feel like I've seen this before. I'm used to having to do this in GDB. But this is in cbtexture.c 549. So this is calling, he like maps this thing and then tries to use the transfer. So the transfer is like a thing that we spit out. Ah, okay. So can we look at like other implementations of this? Like what does like noop do for this? I see. So he does like he sets outputs for this thing. I see. Level, usage, box, stride. Where does transfer come from? So he has this transfer. He creates a transfer for that thing. He creates a resource. Okay. I don't really feel like I understand what this is. What is like a pipe transfer here? Transfer object for data transfer to or from a resource. So I guess we get to, we are like, no, I don't understand. I don't understand. What does it do in like virgl? I see. I see. So he like does some sort of like transfer stuff. And then this looks like it's like configuring a transfer of data, right? And then we can maybe assume that someone here is going to take in a pipe transfer later and extract out a VerGL transfer. Right? Like what's going on here, right? Right. So, oh, this is only a queue unmap though. Queue unmap. Okay. So on unmap, he gets the transfer back and might like choose to delete the data, I guess, which we're just not doing. So if I were to take a guess, I would say that on transfer we upload the data and on unmap we like delete that thing. And maybe the idea here is that you can like pack many textures into like one area or something. So there's like some more advanced behavior that you can do here. Right? Like copy region with blit, for example. Right? Because the transfer has like a box associated with it. Okay. So here they like decide how this thing is going to be used. I see. I just don't really care, I think. I think we just ignore whatever they ask us to do. And just kind of treat it like normal. So, okay. So does this have like the data itself in here? Offset into a driver internal staging buffer to make use of unused padding in this structure. Okay. So resource to transfer to from. So the data is not really here, right? This just tells us like to create the resource, it kind of feels like. So like someone else must use this thing. Okay, here. Texture map, texture unmap, texture subdata. This seems more like what I'm looking for, which has a default implementation, which must have a transfer somewhere. So he gets this transfer and then calls copy box with stuff related to that transfer, which must end up back into our driver somehow, right? It's gotta. He just mem copies. So where does the fucking desk come from? Copy a 2D rec from one pixel place to another. So where is this like destination? It's coming from map. Oh, I get it now. I get it now. We're supposed to return a literally m-mapped texture. Okay, so we could like give a buffer, like a driver structure that like gets m-mapped in and then gets like flushed later, right? There's probably like a texture flush, which actually does the transfer to the GPU. And we can just ignore that. Okay, I think I get it. So my guess here is that we have texture map. We might need transfer flush region. Maybe not. Let's just start with this. And then where the fuck is that defined? God damn it. Here. This is defined in uTransfer.c. Okay. U transfer. This is auxiliary util. Util U transfer H. Okay. No thing called texture. Oh, here, PC. Okay. So here we need. Is this resource? Does it exist? It must exist. It must exist already. So I think we have like Sphero map. Oh, that's already existing. Copy to GPU. This does the M map here. So can we do like static int Sphero map GPU obj. Okay. I think we just need like size t here, which basically does this. And if this errors out, we return null, I guess. And we need to construct our map rec here. Okay. So then we say here, map GPU object with ft GPU handle and size. Is the size used? It is, right? Yeah, it is in the map call. So let me say void star out is equal to this. We call all this stuff. Okay, which means that we should be able to now map a GPU object. Which means we have to like extract the relevant pieces, right? So we have a Sphero context, which comes from the type context. And then we have the screen as well, which is kind of like context. I think is like OpenGL stuff. Screen is like kind of like resource management stuff. Is kind of like my mental model of this right now. So if you're like trying to create a texture, you would create the texture on the screen, but then use it in the context. I think. Then we can look at the screen file descriptor here. We need the GPU handle for the resource. So we have a struct Sphero resource. And we'll call this PR here so that we can do a cast like this. Yup. So then we have PR handle here, right? Which is the wrong thing. It's resource handle. And then he needs a size. Which I don't really know how to extract here. I guess we kind of just need to remember the size of the resource. But I think that actually exists in here. I think that you can kind of derive it from this. I think. Maybe? I don't fucking know, man. And I'm not gonna bother mapping the box. Now we need to say what we have here. So here we say our output thing is a star out transfer is like something like this. And then we do like out transfer. We just copy whatever they did in the new version. In the new version, they copied all of this stuff. Okay. So I think I guess we do like this so that it's easier to work with. And we say out transfer is equal to transfer, which makes this stuff all easier to work with, right? And then this needs a box like this. And then we just have to update this stuff. So the stride is going to be resource PR width 0 times 4, I think. Seems reasonable to me. And then the layer stride, I don't really know what the difference is. So I don't know. Shrug. No idea if this is right. Okay. That seems maybe reasonable, right? Maybe. I believe that map GPU obj. I believe that our object mapping only works for dumb buffers right now. Yeah, see, we can only do it on dumb buffers, which is a problem. It's a little bit of a problem. A little bit. So, but we must extract the textures somehow too. Right? Because we display the texture somehow. That's like a thing that we do. So we have get texture data. And so we can just do the same thing. So we can be like, all right, fine. So maybe the dumb buffer didn't exist. So we'll say if we didn't get dumb, then we'll try to get texture data. And this is the wrong spot. We're trying to do this on mapping. Right? Okay. Then we still use the hardware ID here. And I think we can just ignore, we can do like null, null, null here and just try to get into buff. I think that works. I think that we allow that in libgpu get text data. Yeah, we kind of guard each thing individually. So if we pass in nulls, it's fucking chilling. Okay, so that should fix the mapping stuff. And then I think that means that our kernel doesn't have to change at all because the map API already exists in the kernel. So I think we're mostly chilling there. We just have to recompile QEMU and Mesa. All right, sure. I mean, it's not perfect, but we can kind of start here and just see what happens. Surely we're still gonna like crash all over the place, but you know, I just want to see something. We need to see some form of progress. All right, let's see it. Moment of truth. Moment of truth. Okay. So now we're seeing an assertion at onhandled type at DRM WinSys 291. Okay, so 291, let's go over there. And this is, okay, shader compilation is now failing. So I guess kind of up until exactly now, we've been doing something else. We've been kind of like fix texture upload. I'm not really confident that the texture upload has succeeded, but you know, we can always, you know, dream. We can always dream. Because it seems like it's working. So, what is going on now? We should probably like log what the type is here, or maybe we GDB on it. Test app dev dri card1. Run. He's gonna be like, yo, something's wrong. You hit an assertion. And then can I, at the very least, check out what's going on there? So we go to like frame 5. Can we print out the value of this thing? Text. Okay. Sure. I don't know what we're supposed to do there, but surely something. I guess what probably makes more sense is before we get into this, we should probably do like look at what is trying to be done in the fragment shader. So it's actually looking pretty straightforward. This is a pretty straightforward command. We're literally just calling texture from texture 0, sampler 0. And this is the coordinate. So %3 is the UV coordinate. And we're literally just calling text. So this should actually be like really easy to implement. Like quite straightforward. Right? Because all we have to do is when we see this command, look at that texture and sampler. I'm not going to pretend. I don't think that we're going to use sampler in any way right now. Like I'm sure that there's a reason that samplers exist, but I've never really understood them. Texture here is just going to be which texture ID we are using, which I don't know where that's coming from, to be honest. There's got to be some bound texture somewhere, right? When we call like, yo, please attach this texture at, like when we write an OpenGL app, we call let's see, we've got to find it. We call active texture and bind texture. So we say, hey, take this texture and use that for like the first texture input to our program. And somehow that must like make it into this shader somehow, right? So he has like num textures here. Textures used is probably a bit mask. Just kind of like hand wavy. It looks that way. We have a uniform sampler 2D texture here. So it must be that when we call this sampler is applying, he's looking at texture 1, I think. Well, it says 0 here. This is interesting for sure. Definitely interesting. Somewhere, this GL texture thing must end up somewhere, and we're probably not seeing it yet, actually. That would make sense, because we have to compile the shader before we try to run the program. So let's just fix the shader compilation for now, move past it, and then see if we can find where the texture lives in memory, and then we can like actually implement it. Right? So in here, in shader compilation, I'm literally just going to skip this instruction. Fuck it, right? I don't give a shit. Which means that if I run build here, we should make it past that point. And we shouldn't assert on unknown instruction anymore. Cool, and now we're segfaulting. Probably because somebody's trying to set up the uniform, right? Almost certainly. So let's see where the fuck they're getting mad. Because they're yelling at us about something. Yeah. Texture sampler view from stu_obj. So it's st sampler view 491. Okay. So who knows what the fuck is going on here? Looks like they have some sort of like sampler is looking at some sort of texture. I don't know, man. So this is like a view into a texture used by the shader. All right. Let's just stub this out temporarily and then see if anybody else is yelling at us. Because I think that I want to see like the full picture before I start trying to like freak out and implement something. It looks like template is an input to this, but he's returning a pipe sampler view, which might be important. So can we go into here for now and try to implement this thing? Like, where is our like context setup? Here. Sphero context this. Can we just say creates sampler view? Okay. We'll come back to this, but I think at the very least now we shouldn't segfault at that exact spot. We might segfault somewhere else, but you never know. He's mad about the fact that we need to return something here. And then I think it probably will null check this thing. So can we look at what Noop does? He creates one of these things. I guess we'll just do what they do. This seems kind of reasonable. Seems kind of reasonable. Where their state is the last thing. Okay. Sure. Who knows, but uniform values default to 0, at least for some versions, don't remember, which is why it happens to work right now. In case it helps, you should probably have something like get uniform location, shader texture in your render. Yeah, I would believe that. Yeah. GL uniform I, get uniformation. Oh, so all of my uniforms are pointing to 0, and then I am setting the active texture slot to 0 and binding the texture to it. So if I wrote GL active texture 1, and then set the uniform of the sampler 2D to point to 1, that would be the same thing, I think is what you're saying, which is like my mental model right now. But I don't know. Are there any other resources you'd recommend if I wanted to start learning C? I've always just taken the approach of just like fucking run at the wall and just like try to make stuff and then see if it works. So the only real thing that I would recommend is I used a lot of CPP reference when I was learning, because I would hit problems and then go to CPP reference and read what happened. But I don't have any recommendations for like books or resource or like how to write C or anything, because it's not how I learn. Not how I learn. Okay. Where the 0 corresponds to GL texture 0. Gotcha. I think. Not active texture 0. Atom texture. This is line 292. Set sampler views. All right. So this is probably where we actually write down which sampler we made. So we probably have like some samplers. And then here is probably where we actually write down like, oh, we're going to use this sampler when we run our texture. When we run our fragment shader or whatever, would be my guess. Would be my guess. Oopsies. Okay. So let's do a static here, and then we keep going. We keep going. We hope, we pray that that's the last one, but we never know. It could go forever. Looks like we are not quite there yet. There are more seg faults to be addressed. There are always more. All right. Okay, so this is in set sampler now. CSO context 1401. He is calling create sampler state. Okay. Sure. So this is on the screen now? Yeah, or still in the context. Okay. All right. Sphero, context, create sampler state. Okay. And presumably this has to return something. Create sampler state. Okay. Maybe this time. Maybe this time. Nope. How many? How many do we need? Who knows? It'll go forever. All right. Single sampler done is 1463 at CSO context. Bind sampler states. Okay. Huh. So maybe view. Now I'm confused about what the difference between views and states are. I'm not going to lie. I would have guessed before. What I'm seeing now is what I thought I was seeing before. But now I'm a little less sure. But it seems like this can probably go under the radar for a bit. What was it? It was bind sampler states. Okay. He is mad because I have to write static here, or else he's like, why don't you have a header file for this thing? You can't make a function without a header file. Fucking asshole. Hey, let's go! No more crashes. Of course, nothing is happening. Presumably, we are losing our shit because we are not like using the texture. So he's like, you're trying to fucking pull this thing from this texture, but it doesn't exist. But that's a big improvement. So we'll say texturing checkpoint. Okay. So what do we think we have to fucking do here? My assumption here is that like the samplers we have sampler views and sampler states, right? I don't really know what's going on here. This thing's like, yo, here is target. Which texture are we looking at? What does like our state look like? We have a sampler state looks like is like parameters for how you're doing texturing, right? So things like your mip map levels and all that shit. I think we could just kind of like ignore literally everything here. Nothing in here looks interesting to me. At the very least, it doesn't look like something that that is going to be extremely important to being able to use the texture. It seems much more likely that the pipe sampler view is the interesting thing, right? Because he's pointing to, this guy tells us which texture we want to look at. So when we set the sampler views, okay, we have create sampler view and set sampler view. These should probably live next to each other. So when we create the sampler view, we should probably set the texture to the texture, right? And I assume that this will come in with like a real texture for us to write to. And then I assume here that we should have one view, and we should just be able to say, yo, here's my fucking texture. Now, obviously, Obviously, we're skipping some steps here, right? But I don't care. So what I'm gonna do now is just gonna say Sphero resource here. This is going to be the shader texture, which like sampler texture. This is obviously wrong. Obviously wrong, right? There's a couple levels of direction that we're ignoring. But for the interests of finishing this today, we're just gonna skip that, right? And then all we have to do is say that we have a context here. We're gonna take our Sphero context is a cast of the generic context. And we can say context texture, sampler texture is literally just like views 0 texture. Let's get crazy, dude. And I guess we have to do struct Sphero resource here. Right? Fuck it. Fuck it, fuck it, fuck it. The motto of today. Which means now we can, since we are making like a sweeping large fucked assumption that we always will just have one texture bound, it means that here all we have to do is pass in the UV coordinate. So we can look at like print ner print. And in here, we should have some sort of like ner inster type text. He's going to print a text instruction here. So we see this is interesting for us. So let's kind of pull this. Boom. Okay. Then we're going to do something with this. We're going to say like, what are we? Ner text instruction text is this. And we just need to fucking find the inputs of this thing. So I don't give a shit about any of this stuff right now. I'm sure this is important. Regular texture lookup, LOD bias, like, but you know, in reality, we're gonna treat every single text lookup exactly the same. Because we're lazy shit. Then somehow we must look up the UV coordinate that we're pulling from here. So can we run this virtual machine again? I just want to look at the fragment shader print again, because it should give us some form of clue. Print fs, here we go. Let's fucking see it. Let's see it. So he's calling chord. The chord is the reference to the thing in 3. Okay. So we're looking for chord. So it looks like he like iterates over sources. Right. I guess for now we can just like, it looks like we only have one. We should only have one. So maybe we'll just assert that text num sources is equal to 1 for now. Okay? Then we need to print this thing somehow. So we just have source. Oh, fuck. I keep using the wrong jump. Okay, so we just have text source 0. Source SSA. What the fuck is going on here? This is a ner text source, which has a source. And this, oopsies, has a SSA. And we've used SSAs before, so yeah, just the index here. So that's where we're going from, and this is like from, and then we have some sort of like to as well. So we have like def here, and then we want the index. Right? Is that what we do other places? Yep. So now we should be able to just push. We should be able to like do like GPU shader push text sample, and we're just gonna sample from here. We're gonna output to here, and we're gonna sample from this. Okay, simple. Very simple. Very simple. And then all we have to do is add that as like a command that we have in libgpu. So can we do like copy and then go to libgpu and add that as like this? And we're gonna be like, here's where we're coming from. Seems reasonable. Seems reasonable. Now we need to add that command. So we need to take this and we need to go to our shader C bindings and just kind of shove this somewhere near all our other commands. Boom. Pub export function, this thing, return a bool. We are going to take in our shader as a shader builder, our ID as a U32, and our source as a U32. Which means that we're going to make a command that looks very similar to this, except it's going to be sample texture. We're going to have the output as ID and the source as source. Okay. Which means that we need to add this sample texture command. So we're just going to be like sample text. He takes in the output as well as the source. Right? Was that what I called it there? I called it output and source. Yep. Which means that whoever runs this stuff needs to call sample texture. And here we'll just write panic unimplemented texture sampling. We'll get there eventually. We will get there eventually, but not right now. Does that compile? Looking promising. Looking promising. Which means that we should be able to go back into Mesa. And this should take in our libgpu shader as well. Okay. Which means that this should build. Looks like he doesn't because this is an invalid initializer. Why? Maybe it needs a star on it. Probably. It's probably a pointer. That cough scared the shit out of me. Sorry. sorry. Okay. Okay. And then, are we chilling? We can just kind of like quit Ninja. I think I want in libgpu to record stuff. I think we want like this to be graphics inputs JSON again, which means that then we can recompile this, run it, and just hope that everything works. So here we should be going into source Mesa, running build and copy and run. and just hope something interesting happens. Okay, so this is good. Inputs are being recorded, except our recording now needs to look at the sampled texture, which is not being done right now. Okay. So in Mesa, if we are assuming for now that we have a bound texture, it means when we do our thing here, we're just going to say for now this. Right? It's not great. Not great, of course, but we'll make it work. So we need to basically tell the GPU, hey, this guy's gonna look at a texture. Please, like, look it up for me. Which means that the Linux kernel needs to add this as a thing that tries to pass on to the GPU. So I think, again, it makes more sense to start on the GPU side. So we're gonna call like draw exec shader pipeline. Here, let's just add in one more thing. So this is going to be the sampler handle, we'll call it. And then this guy is going to pass in the sampler handle here. Yeah, fuck it. Which means in the Linux kernel now, when we call execute graphics pipeline, we need to like pass that thing along. So exec shader pipeline. So we put it at the end. So 15, 6, fuck. 15, 6, fuck. 15, 16, 17. And here we need to look up the sampler texture, which is going to come from params sampler texture handle, which doesn't exist yet, but that's fine. And there's going to be sampler texture here and here. And we're going to make sure that we didn't make the same mistake that we made earlier and make sure that we're not fucking clobbering things. 12, 13, 14, 15, 16, 17. Okay. And then here, this is fine. Okay. Sampler texture handle. Okay. So nothing to worry about here, I don't think. Let's rebuild the Linux kernel. Rebuild the kernel. Oh, we're back in the case where it's building a lot of stuff. Who knows why? Unknowable. It's really unknowable, but it'll take a sec. Then we can rebuild Mesa to pass in that thing that we should be chilling. We should be. Are you doing minimal OpenGL 1.0 compliancy? No. We're just kind of like trying to run a application and we're not really caring about like compliance at all. We're just like, if it's like approximately at all reasonably correct, then we're happy. Okay. So this needs to be sampler texture handle. And this thing should build now? Yeah, he built, but he can't upload. So let's just make sure again that I'm not confident that we rebuilt libgpunit in its latest state. And then we can rebuild qemu, send everything over. And I think that's everyone. This guy's mad because libgpu does not take in the depth, the sampler texture. So can we make that happen? So on execute graphics pipeline, we added the unit64t sampler texture like this, which means in lib.zig, we need this guy to take that in here as well. Which means that this guy needs to write that down. Okay. And then, which means this guy needs to kind of figure that out as well. And then we need to return that here. Okay. And then all we gotta do is have that as an output. Okay. Shallow copy of textures. Data. Okay. And then if we run this now, we should get a recording that we can work with. Hopefully. Oops. How have you been doing OpenGL stuff? I don't really know. Not a, I feel like I've like touched it for the first time a couple of years ago. I don't really think I'm like that good at OpenGL though. If you're asking how long I've been trying to like create a GPU that interprets OpenGL stuff, like maybe like a month, probably a little less. Right? We've been working on like understanding Linux graphics stack for like I think like just over a month and a bit, but I think that the OpenGL stuff started pretty late. So hard to say. Is this build now? Looking promising. He's linking. We love to see him linking. Let's hit run. And we will see what we see. So let's make sure we have the latest and greatest Mesa over there. We send it, we run our shit, and we're just hoping to see, that, hold on. We're hoping to see a sane, sampler texture in this file. Fuck. This file? Fuck. This file. No. Graphics inputs JSON. Okay. So we see something. It's got a like a metric fuck ton of Zig uninitialized memory. Right? So that's a pretty good indication that our upload of data is not working the way we want it to. Which is a little confusing. So that the assumption here would be that either our mapping is not working correctly in QEMU, the mapping of pages back from texture data to user space, or we are not correctly copying the data in user space. So I think probably the play here is to try to look at the mapping code that we changed. Is there a greater purpose in mind for such a project, or just doing it for the exploration of knowledge? So the intent was that we wanted to understand how, like, what would go into making a GPU. One day it would be fun to like buy an FPGA and try to make a GPU that works. And I don't really care if it's going to be OpenGL compliant or whatever, but making making a fake GPU that runs through the OpenGL pipeline gives us a clue as to like what a real GPU should do with like modern API expectations. Of course, obviously OpenGL is like an outdated API compared to Vulkan, blah blah blah. But like the idea that like a GPU executes shaders is like something, like I didn't really understand how that concept is broken down, and now I feel like I understand that concept a lot better. So that's kind of like the intent here. It's kind of the intent. Okay, so this seems like it's kind of working. Hand wavy. I'm not seeing this like failed to map log. I don't think. Yeah, I don't see like a failed to map anywhere in here, which makes me think that the mapping is either not being called or is working correctly. Now, it's possible that we're never trying to write anything into that data. That seems very possible. So I would maybe be interested in when we try to like map the texture, I would like to just mem copy something into this thing first, just to see if we can see that show up somewhere. Because that way we can tell if there's a problem with the mapping code or the calling code. So if we just say, like, shove a bunch of 0xFFs into this thing. So you want to take the void star s and the number. So we're going to take like the size here. Right, okay, gotta go like, what? Let's just kind of see what happens when we do that. So before we were saying 170s everywhere, because that's classic zig uninitialized memory. But if we turn this into 0xFFs, that's huge for us. So we'll give him a sec. We want to see him start printing out that he has written out some data again. Instead we're seg faulting. Interesting. Interesting. So what's going on there? That's really unexpected, actually. I might have missed that before. Yeah, so we're returning null here. Why? Map GPU obj takes in a GPU handle. How can this thing fail? Because I mean that's gone like the Linux side, and I don't think the Linux side should be able to fail that like at all. I guess if it doesn't exist. If he doesn't exist, can we write down if it's like what the error code is? Ooh, Prospod, thanks for the raid. Much appreciated. What's up, you guys? What's up, you guys? We are working on our virtualized GPU. We are trying to get texture mapping working, and we're currently in the middle of trying to transfer texture to the GPU for sampling in a fragment shader, where the fragment shader is like compiled by Mesa, uploaded to the GPU. He says like, hey, I'd like to sample from this UV coordinate. We're doing like triangle interpolation to figure what that UV coordinate is based off like vertex attributes. And we are supposed to then just like look at the texture that has been given to us. I mean, we were struggling with sending that texture over. So that is what we were trying to do. Okay, so he's saying map failed. Can we write y? Let's give us a little erno. Unless, yeah, Dermactyl I think just calls octal with like an e again loop in it. So can we see why he hates us? But yeah, shout out Prodspod. Thanks for the raid. So he's saying erno 22. Where do his like erno numbers? Here we go. This is probably it. So 22 E in val. So he's claiming that we are trying to map a handle that doesn't exist. Okay, why? This is coming from resource handle. I wonder if this resource, like, does he not exist? Are we supposed to make it here? Surely not. Surely somebody's already created the texture. Surely. Let's pop open the debugger and take a look. Let's take a little peek skis. Okay, so we are at like frame 1. And can we print out resource 7? Okay. And he's saying resource 7 doesn't exist. how are we creating textures? Is our like texture creation not like creating like kernel mappings? It is a different API. So maybe we look at the difference between whatever octal we're calling here, alloc GPU obj versus create gltex. Alloc GPU obj versus create gltex. Alloc GL create gltex versus alloc GPU obj. Okay, so this is create gltex. Alloc GPU obj. What's the difference? Gem Sphero create with no way to map to user space. Ah. That does look like a comment that's indicating something bad. Can we just take like params, width times params, height times 4, and just be like, assumed format of RGBA32. For now. For now. Right, let's just see. We'll see. So we have to build the kernel again. I like that I had the exact like comment there that I needed. I was just like, oh yeah, this is like, this totally fucks your shit up in this exact case. I'm like, oh, I'm in that exact case. That's kind of fun. So now if we run this again, I wonder if we're chilling. That would be cool. That would be cool. Test app dev GRI card 1. We are seg faulting now at writing the texture. I think we've seen this bug before. We have to, it's because we are probably writing to the end of the texture. And I think that we have, we fuck that shit up. Because we take like a uint64 write and we say, oh, we're only trying to write 8 bits of this 64 bits. And we like take the first values and we like mask those off, but then we still write the whole 64 bits. And so if that ends up on like the end of a buffer, we just segfault because we go out of range. I would expect that's what we're seeing here. And we've hacked around this in the past by just like over allocating our buffer. It would be nice if we could see our fucking arguments. Okay. Yeah, so 4 byte, right? Can we see like bar adder? Optimize that. Fuck! I'm not sure. It's hard. I can't remember what's going on here. So resolve bar adder. Let's look. So we take in an input and we say, here is the pointer to the thing that we're trying to write to. And here's the mask of that thing. Okay. So can we look at... Oh, fuck. Okay. I guess we can put a log here. We can put some logs. Page X, pointer, number, page number. Writing a page number as base adder this, writing offset in hex. With size this. That should give us a bit of a clue. So then we have to just point in page, base adder, offs size. Okay. That should give us a clue. He's mad because offset is an int64. So we do that. We put a little x in there. And then he's mad because page also is an int64. Okay, we're chilling. We're chilling. And I guess we run it again and we just see how it falls the fuck over. Root, test, app, dev, GRI, card one. Yeah, so most of this is fine. And then he eventually I think, is this the end of the page? FFC with size 4. That sounds a lot like the end of a page. If a page is 4096, that's 1000. Yeah, so this is just the out of bounds access thing. This is just that problem. So do we just fix it? Like if we do this, we do like a cast to a unit 32 T star. Right? Like right? Default. And default is we do whatever the fuck we were doing before. Maybe. Maybe. Can we get rid of the print now? Because that print was like just destroying our runtime. I think that fixes the problem. I don't know why I didn't just do that before. The hack that we did is actually kind of harder to deal with than just doing it right. That's such a classic. You're like too lazy to do the right thing, so you do something harder. That's such fucking classic programming, man. Okay, test app dev DRI card one. Let's see it. Okay. Why is it spamming failed to get dumb buffer? Oh. I know why. I know why. I don't know why this seg faulted though, but I do know why it's spamming failed to get dumb buffer. That's likely. No, I lied. I don't know why. I lied. I'm a liar. I'm a stupid, dumb liar. Okay. Let's start here. Okay. Failed to get. Oh, that's actually fine, I think. I think that just means that he's trying to map a texture. He tries to map a dumb buffer before a texture and then error logs. I think that's just part of something we do in here. In lib.zig, we call it failed to get dumb buffer. Yeah, which is just like, this is just not an error anymore because that might be true. We are now failing on texture unmap, which kind of indicates something. It kind of indicates that we got pretty far here. Text from image. Text from image. This is at in our test app. we are looking at model render from the text from image. We are at text image 2D. He's trying to unmap the texture. Oh, yeah. Okay, wait, this means that we're actually farther than we've ever gotten before. We've probably successfully transferred the data to the GPU. And that wasn't working before. We didn't see this crash before because before the map failed, so he just didn't do the copy. Right. Okay, this is good. This is good. We're fucking moving up in the world. So we go into Mesa. Textures are pretty big, bigger than a bar. Does Mesa chunk texture uploads for us? So we in our Linux kernel, we have a bar that is some size. I don't remember. Many pages. Many pages wide. And what we do is we have in our mmap handler for our GPU resource, we like map pages into that bar as we need. So like we have like a PCI card exposes like bar 0, which is like command bar. And we have bar 1, which is like data. So what happens is we send a like alloc command here, which will like create a texture on the GPU. Then we send like a new command here that's like map. And this will be like, could you map texture 4 to off page 3 to bar 1 at page 5. Right? And so then what we can do is in our kernel driver, we will like when somebody calls mmap, we have like a handler for when they page fault. So they call like a user will call like mmap down here, right? mmap. And that will give us some sort of like pointer. And we'll try to like that will like do nothing, essentially. If we write to that pointer at like we do like x plus 5 is equal to 4 or something, right? This will page fault. The kernel will say like, I don't know where that is, or like and the kernel will call into our function. And in our function, we'll be like, oh, fault. Well, I know that this is GPU object 4, and I know that this plus 5 is at page 0, and I'm tracking. I know which bars I currently have mapped. So he'll just be like, can you map this up at like page 4 in the data bar? And if something already exists there, he'll be like, anybody who's like thinks that you have something mapped there, just like evict that thing, and next time they write there, like page fault again. This is a very slow ass way of doing this, but it's like good enough. Shit. I'm 2 minutes into an ad break. I sure fucking hope that I didn't explain all that to whoever asked without them seeing the answer. That would suck. Oh, cool. Good explanation. I got it. Thank God. Let's go. Okay. So now what do I want to do? We have this thing uploaded and we need to implement the unmap call. So there was texture map and then there was texture unmap. And for now, we'll just go Sphero texture unmap. And we probably should get the right function signature here. And we can get away with, I think. Where is the like data buff that we returned? Right, we called this, but the data didn't end up in like the transfer at all. Are we supposed to stash that shit in here? No. So maybe we just do nothing. Maybe like the caller of this thing will call munmap for us. That'd be kind of sick. Because otherwise we just don't have the data we need. Right? Like what I want to do here is I want to call munmap on data, which we returned here. But that's just not fucking here. So like, you know, what the fuck am I supposed to do? So I'm just gonna make the assumption that somebody else unmaps it for me. Which is maybe a bad assumption, but it is one that I'm willing to make. Okay. Clearing worked. Okay. What is happening right now? We are taking a long time to do something. I don't see any logs indicating that we are writing out anywhere. Are we drawing right now? I thought that we were supposed to be in recording mode. Oh, here, it's recording. Okay, wait. Okay, that's good. Can we look at what's in that recording now? So can we... Okay, so we're seeing a lot of zeros. Okay, that looks like texture data, baby. I mean, it looks like something. Right, we're seeing some, like, stuff, zeros, stuff, zeros, stuff, zeros. And if we were to, like, actually look at the texture that we're trying to map, how does that thing look? You know, is that full of zeros in some places? I think it is. I think that the background, the alpha, I think that all of this stuff is actually zero. I think the background color of this thing is, yeah. See, anything that is zero alpha is just getting like displayed as nothing. So I think that's probably right. Probably, which is pretty sick. Now it's absolutely slow as all hell, right? Shut the fuck up. But I think that means that we can start working on getting a replay to work. I think. He's mad because there's a missing field here. Trying to load the thing. Oh, because this is supposed to be graphics inputs plural. That's a really good sign. So unimplemented texture sampling. Let's fucking go, baby. Let's fucking go. So it's funny because I think that our since we're storing this thing, we have a 34 megabyte JSON file. That's pretty funny. So let's turn on optimizations here to try to get this thing like a little bit down on like loading time. It's because we're storing like an unbuffered texture just like raw in JSON. It's like the stupidest way to store that shit. But it hasn't been a problem up until now. So, you know, we only fix things when there are problems. Okay, there we go. It's running way faster now. Okay. So let's go into our shader executor. And it should be pretty fucking easy to fix this. Should be. So we just have unimplemented texture sampling. And so we just have some texture, right? And so now we must have to look at that texture, right? That's going to be our, you know, the kind of expectation here. So how are we going to handle this? We have UBO passed in here. Can we just pass in like sampler texture here? Obviously, again, this should be parameterized, but also, again, you know, we don't give a shit right now. Maybe this is just a texture. Const text libgpu is equal to import libzig. Okay. We pass this thing in here. Okay, which means that here we probably want this thing. Okay. And then now we can just look at that thing. So we're going to be like sampler texture. Probably need the stride, right? Surely. Uh, you probably need the height as well. Surely. And we're basically being like, yo, give me the stuff from one thing and put it in another thing. So we're going to look at like the data that's in like t.source. This is going to be like the UV coordinate, right? So we're going to like assume that this is a vec2. We need to like resolve the reference. So here we're going to be like, source is going to be from t source. Source like this. We say, yo, give me that UV coordinate of that bad boy. And we're going to say that the x value is UV dot, hello? UV1, I guess, UV0 times the sampler texture dot width pixel. Y is going to be U1. We need to do a float from int here. And then do as f32 here. So we're going to do like the same thing like this. Okay. And now we're going to call we need to get these from UV like this. Oopsies, like that. Okay. This is times height, I think. And maybe this is times stride. Maybe not. So we're going to go y times stride plus x. No. I think we don't need the stride here. It really depends on what the output of this thing is supposed to be. I think the output of this thing is supposed to be like an RGBA floating point value. So if we are sampling a texture here, we are going to have to extract all of the RGBA colors from this thing. So I think it probably makes sense to actually, we will use this thing as stride. So then we can do like const start is going to be the y times stride plus x times 4. End is going to be start plus 4. Actually, we don't need end here. And we're just going to look at like the sampler texture data at start. This is going to be the R, right? G, B, A. Wow. Wow, 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 right? And then we just say that the output is going to be a vec4 of those things. Yeah. I don't know. Expected expression, found this. I was supposed to put a dot here, and then I guess we're just gonna like do like something like this. I don't know, man. Float from in. This is bad. This is bad. This is bad. This is bad. This needs to go here. These, I want these as F32s. We want to do float from int here. Like this. Okay, and then we're gonna do A over 2, fuck my no. B, R, G, B, A. All right. Maybe. Maybe. Could throw in a percent width, etc. at the end of force GL wrap and GL repeat. More importantly, prevent possible out of bounds access. Yeah, I'd agree with that. So can we do this as a int from float? How do we want to do that then? Probably like this, and then put these as like I-64s or something, and then do like y unsigned is y percent height, uh, and xu is x percent sampler texture width pix, and then do like int cast here. Something like this. And then here we use x, u, and oops, y, u, and x, u. Okay, so usage of execute on buff are a little bit bad, of course. So I think it's in here. So here we need to pass in the inputs sampler texture. And then here we need to pass in inputs sampler texture as well. So that when we don't really need it on the vertex shader, but we're passing it in because the API is telling us to. Because again, we're taking shortcuts today. Okay, this is going to live here. This is going to say we have a sampler texture. And then we just have to feed this bad boy to the shader when we run him. So down here. All right. Let's see if that's a little happier. He's still mad, actually. Expected 5, arguments found 6. Oh. Okay. Sure. Where? Oh, these are because we have a little bit of extra wrapping. Okay, let's try this. This. And then do the same thing here and here. I think that's how we did it. Something like that. He's mad because expected type usize found texture at libzig 140. Execute on buff. Oops. True. Big true. Let's put him here. All right, let's try that. Unexpected expected integer type found after 2. That's true. These are already floats. I don't know what I'm fucking smoking. Maybe I'm smoking it. These should be floats because they are widths. True. True, true, true. Okay, and then y cannot be modded by fucking... Oh my god. Oh my god. Come on, man. Fucking cats everywhere. Cats everywhere. Remainder division with I64 must use mod or rem or something. Oh! I'm gonna lose it. Oh, I'm gonna lose it. Maybe that means that this was actually fine. Let's double check. Is that fine? That's fine, it looks like. So it looks like it was more complaining about the fact that I'm not supposed to use percent on integer types. What's the difference between rem and mod? I actually don't know. Oh, baby. Oh, baby! Look at that! I mean, it's wrong. I mean, it's not right. But it's close. That's a fucking textured monkey, if I ever assume. It's fucking grayscale, right? Maybe it's just too blue instead of brown. But like the eyeballs are right, which means that the texture mapping is like for the most part correct. That's fucking sick, dude. So let's just try swapping the red and blue channels. I suspect there's a problem in there. Built-in color correction, ship it. Fuck yeah, dude. Let's see. Come on. Send it my way, please. Mwah. Please. Let's fucking go, dude. That is awesome. That's actually so sick. That is so fucking sick, man. So let's turn off the recording system now and see if it works. Like, let's see if we can, recording path. We set this back to null. We compile this in release mode. We don't fucking run all this shit. And let's fucking hope to God that we're done, dude. Because we've spent so much time on this. I'm getting tired, but if we get, like, the driving it home is so fucking worth it. That's so fucking cool. Okay, so recompile QEMU, and let's just see if we can get that bad boy rotating in the fucking QEMU output. Run. That's actually so sick. It's actually so sick. I was like, no way we get through all the to-dos for today when we started. Well, I was willing to go to like 7 o'clock tonight. I was like, I want to be fucking done. So, and I said that it was the last stream. So I was like, you know what, fuck it. If we need to, I'll fucking run it. Oh, that is so fucking sick, man. That's so fucking awesome. That's sick. I can't believe it works. I cannot believe it. That's actually so sick. So for if people haven't been watching like kind of consistently in the past month, because like, you know, why would you? This is a software rasterizer that is running a GPU shader compiled by Mesa. So there's a vertex shader and a fragment shader. The vertex shader says, here is a transformation matrix, and here is a bunch of vertices that for this monkey, right? That's like uploaded to our GPU. And like the program is like compiled into this, like, you know, some sort of like Sphero intermediate representation that's just like a JSON blob. We then pass all of this like data to the GPU, right? We pass like the vertex buffer and the texture up to the GPU and say, run the program on these inputs, where we have the texture, the vertices, and there's perspective transform. Those are all like uploaded to the GPU, and we say, can you please run on these things? The GPU then like runs the compiled program and like reference, like for the vertex buffer, will come out with like a list of 3D points that he will interpolate using barycentric coordinates, perspective corrected. Then he runs the fragment shader using those like interpolated values within the triangle for each pixel. That fragment shader will sample from the texture, and that's pretty and like that's it. I mean, it's not a lot, but getting all this working was a lot of work. So I'm pretty happy with this. I think I've answered all of the questions that I wanted to answer. Right? Like, we started this project with the idea of, I wonder if I still have like my initial diagram like kicking around somewhere. I might. Not here. Maybe on the desktop though. There's like a chance. No? What about like here? Why GPU? Yeah. So this is what we started with. Is we were like, what is all of this shit, right? I was like, I understand that like my computer has a graphics card in it. He's connected over PCI. The CPU can like talk to this thing. He displays things on the monitor. And I understand that like we write some sort of like OpenGL app. And then this whole thing is like, I write some OpenGL shaders. How the fuck does that end up over here? I think they've like very like successfully answered that, right? We understand that we have like a kernel module. He talks to the PCI card. He has like a list of commands that he can send. He has the Mesa driver for this thing will compile OpenGL into like a format that the GPU can execute. he has like a lot of like buffer management in both the kernel and Mesa, right? The kernel needs to keep track of like GPU object allocations, and like if we need to map those things into user space, he needs like a way to do that, or a way to map like kernel memory into into user space, and then like lazily copy that shit over. We've seen a lot of that as well. We understand that like displaying to this screen is like not super trivial. There's this like concept of like DRM, and like you have to like ask the monitor, like the GPU has to tell you what resolutions your monitor supports, and like he might be, there's like a frame buffer that like the GPU has to know about and has to know how to display that thing, and that has to be like set up by the kernel driver and all that sort of stuff. Then you have like an OpenGL driver. We like ask the GPU driver. We open up this file dev DRM. We say, "Yo, what kernel driver are you?" And he says, "Oh, I'm a Sphero GPU." So then our Mesa implementation can like dynamically load some like shared object that's just like fucking sitting there, and say like, "Sphero GPU.so, please do work for me." Right? And all of that work is like things like creating a texture on the GPU, uploading data thing on the GPU, like pretty much that stuff, right? As well as like shader compilation and resource management. It will like talk to our kernel driver that has custom commands for whatever our GPU wants to do. Yeah, and so like the answer to the question that we started with of like, what if I wanted to make a GPU? What do we really want to do? It's actually not that much, right? It's, if you were to cut out all of the Linux and OpenGL bullshit, but still try to do something that's like functionally equivalent, you would basically have some sort of like language, like some sort of like compiled language that you use, right? Like in the same way you have like x86 assembly or like ARM assembly. You would probably have something that's like very similar to that, with instructions for things like sample a texture from this thing. And or maybe even not that, right? Maybe a sample a texture from this thing could compile down into some like lower level representation that's just like, you would probably want something that's like sample a texture, right? Because the idea of like XY times height width, like width times height plus stride, or something, sorry, stride times height plus width, that's probably something that you would want to like encode in there or something. But you know, it's there. But really all you would have to do is like create like a CPU, clone it a fuck ton of times, and do like the triangle rasterization stuff. I guess that stuff's kind of hard, right? Each triangle that is being drawn here is like taking the output of the vertex shader and like interpolating and figuring out which pixels are active and stuff. So there's probably like doing that in hardware would be like kind of hard. But yeah, I mean, I think I'm pretty happy. I think I understand what a GPU should do, and I think this is like a really nice resolution to the project. When was the last time we finished a project? That's also kind of crazy. I mean, we're calling it finished because I'm willing to just stop. But yeah, pretty exciting. Pretty exciting. So thank you for watching, guys. Thank you so much. If you like what you saw, too bad. There's no more. The GPU project is finished. So what we'll probably be working on next is I want to spend a little bit of time on like, I want to work on an image editor, I think. I'm not very good at GIMP or Inkscape, and I feel like there is a solution to that problem. And instead of learning, I kind of want to just make my own. I think that there's like, I have a lot of ideas for what I want out of an image editor. Like I want to be able to, I want it to be kind of like Blender. I like the idea of like a scene hierarchy that like I don't really see in GIMP. I like the idea of transforms that are like recorded in and editable in history, right? So if I do something that I'm like, I want to select this thing, cut it out, paste it over here, and then like attach it to this object and move that object around, like I would like to be able to go like back in time and edit that selection and stuff like that. So I have like an idea for like something's like vector graphicsy, like blendery, shaderful, and can like replace GIMP and Inkscape usage for me. And that's kind of what I want to work on next. So if you want to see that, you can swing back around. We'll probably be doing like a few smaller bits and pieces for the next few days. I think I don't want to start on like that full thing right away. So I think probably looking at like image decoders and maybe like window management. I've been looking at like the idea of pasting images is weirdly non-trivial if you don't want to use GTK. So yeah, we'll be back around with some fun stuff, but no more GPU stuff. So we'll be back. Probably I'll take tomorrow off and start Wednesday. So hope to see you guys then. Yeah, thanks for watching, and I think we'll say goodbye to YouTube and Twitch. Let's find someone to raid.